Hi together and welcome to today's webinar hosted by the Open Telekom Cloud community. Today we have two guests here, both of them again from IITS Consulting. One of them is Alex and one of them is Dennis. Hi together.
Hello everyone.
So with this, I will lead over to you, Alex, and wish you all a nice and very great webinar today. Thank you.
All right. Thank you very much, Stefan. Hello everyone once again, and let's start our webinar. The topic for today is a battle of GitOps tools, Argo CD versus Flux. Let me please shortly introduce speakers for today. I'm Alex. I work at IITS Consulting as a head of cloud infrastructure and operations. I'm working in the DevOps area since 7 years. Before that, I was doing programming, and I'm looking forward to learn all new technologies in the DevOps area. Dennis, could you please introduce yourself?
Yeah. Hi guys, my name is Dennis. I'm working as automation consultant in IITS Consulting Company, and I'm about 6 years in DevOps world and pretty much interested in also new features, new technologies, and new stuff. Alex?
Yep, thanks, Dennis. Okay, let's go on. A few words about our company. We are IITS Consulting, a young company which was founded in 2019. And what we do, we provide agile cloud native development teams that help businesses automate their complex processes. We are growing quite fast. Right now we have 40 employees, and since a while we became a silver member of CNCF Foundation. All right, let's talk about agenda for today. First of all, I will make a short introduction to the concept of GitOps so that we are at the same level of understanding. Then Dennis will introduce you a dummy application that we will try to deploy to different clusters using different tools. He will do this with Argo CD. I will do this with Flux, and then at the end we will have some summary and key takeaways to talk about. Okay, let's go. First, a little bit of theory. What is GitOps? The term GitOps was introduced by the company vWorks back in 2017. It is a way to do continuous delivery and operate Kubernetes via Git, which means that there is no need to run kubectl commands manually from the command line. Instead, the only thing you need to have is Git. This means that Git repository is a source of truth and represents a cluster. So it means that everything you have in Git is in your cluster, and vice versa. Everything that is in your cluster must be persisted in Git. The main advantage of doing GitOps is that it empowers developers to do operations, because knowledge of Git is something that pretty much all developers have. And as soon as you can Git, you can be a cluster manager. There is some small thing that should be slightly adjusted before you're doing GitOps. Your CI/CD pipeline should be separated into clear CI and CD parts. So what will the CI part responsible for? First of all, upon each Git commit, for example, to the main branch or to any other branches, it will build new images and then test these images, so it makes sure that the application application in the repository works. And if everything is fine, it will publish new images to the Docker registry. And that's it. CI part is done here, and then CD part joins the game. And CD operator periodically checks for new images in the registry. And as soon as there is something new, it combines Kubernetes objects from different sources together and basically kubectl apply them against the cluster. So it's doing this job that usually people do manually. And then Kubernetes cluster by design will know how to achieve the desired state. So this is the new pipeline that you want to need in order to execute your GitOps. And now let's proceed to practice. Dennis?
Let's dive a bit in a practice, and actually to have something to show, we need a Git repo and some dummy, some basic application that we will use. So what we have for today, we have some Git repo with Go application with Docker file, and also we need some CI process to have these Docker images somewhere, and we decide to use OTC software repository to store our Docker images there. So yeah, and also we will need some repository that will have infrastructure inside. Yeah, the point where we will describe our infrastructure, we have also the second one. Yeah, and inside of it, we will store some YAML files that will describe our applications or our infrastructure, etc. And also we will need some OTC container engine with Kubernetes cluster inside, yeah, and some GitOps agent inside of it, inside of this Kubernetes cluster that will actually try to pull some changes from the Git repo and try to converge the states. The state of our application inside Git repo should be converged with the state of our application inside Kubernetes cluster by this agent. Yeah, and this is how our application should be available, should work inside Kubernetes cluster. Regarding application itself, it's just a Golang without any frameworks or anything else, and with some external dependency as a Redis, and with stupid name Argo CD versus Flux CD application. Yeah, and also what it can do, it just reads an environment variable like Redis URL, check the Redis availability. If it's not available, application will throw an error and container will be restarted. Just write some random key value to the Redis, read this key value by ID, and print it to stdout. Pretty simple without any logic. Yeah, and this is the output of this application. Just try to ping Redis. Redis is okay. Okay, I will try to send data and read them back. That's it. Also, we need some CI process. Yeah, we need something that we will use to determine that this version of our application is like stable in quotes, and this version is unstable. And we decide to make it as simple as possible. Just decide that this application we will call stable if push was done in the main branch. And in that case, we will use version like 1 dot something, and yeah, this is our stable application. And unstable here is just something that was pushed not to the main branch, and in that case, we will have version like 0 point something. As you can see, sorry. As you can see also here, we are using SWR, so it's really easy as usual container engine to use OTC SWR for this case. Yeah. What actually we have? Yeah, we have a minimal setup like GitHub repo, Go file, Docker file, some GitHub Actions CI files. We're pushing something to the Docker SWR registry, and that's it. We have some versions of our applications, pretty easy. Yeah, and let's check a bit again this theme. So we have application, and this is just some basics. I think all of you using something like the same. We will skip this part and we will concentrate on this part, on this infrastructure repository. We'll mostly talk about this infrastructure because we are interested in CD and in GitOps in this presentation, yeah? And how we will describe our application. So as I said, we have some agent inside our Kubernetes cluster. It doesn't actually matter which agent we will use, Flux or Argo, something that will pull state from GitHub repo and try to make the states equal. State that described inside Git repo and state that real state that you have inside your Kubernetes cluster for your application. Yeah? And also, I need to mention that all this infrastructure implications, these repos are available in the GitHub, so you can use it for your needs. And please welcome to fork it or make any pull requests. And now, finally, let's talk about Argo CD and how this pretty cool tool can help us. Yeah. So what is Argo CD? Argo CD is actually the GitOps tool for Kubernetes, just spell it again. Yeah, and this tool can help us to describe our application, this application's configuration, so environment in some Git repo. Yeah. We can describe it in declarative manner with version control because we're using Git. We have a history, etc. And as a result, you will have, you should have, by using Argo CD, or you should have auditable. Sorry, forgot about this. You should have auditable, understandable, and automated deployment process. Basically, it's not just standard deployment process when you need to make some Helm install or kubectl apply or something like this. This is more about convergency. You don't need to execute some comments. You need to store description of your application somewhere in Git, and the tool should care about the next parts by itself. Yeah, and this is a repo that we have actually. On top of it, we have a chart because it's just simple for us to use a chart to describe our application. It can be customized template, it can be plain manifests for Kubernetes, but we decide to use chart. I decide to use chart for Argo CD, yeah. And next is the install directory with values override. The simplest way how you can install Argo CD in your Kubernetes cluster is just use Helm chart, yeah. And to have some specific for us, to have some configuration that will be specifically made for our case, we should override some values inside this Helm chart, and this is why we have values override file. And also we have stages just to show that we can have separate environments, yeah, and separate configuration for our application that depends on the stage. We can have different databases, different, I don't know, whatever, secrets also. And yeah, let's take a look in values override file that we are using to install our Argo CD. Here it is. This is pseudocode, yeah, you know, because it's a bit bigger than the display, and you will not see lots of additional stuff, but it's not important. As I said, you can get it in the GitHub. The most important things, they exist here. So here you can see the repositories, yeah. Basically, you are describing here some Git repos or some Helm repos. It's not too much. It's not really complicated. And this is an interesting part. It's this part called additional applications. So when you install Argo CD, you can say that you want to have out of the box, after install of Argo CD, you want to have some applications to see some applications already there. Yeah. And also we see here app for apps -dev. That means that we will use app for apps pattern. This is some kind of bootstrapping for the Argo CD. Let me explain. So you will install this bootstrap, and this bootstrap will try to get any applications in some specific directory in your Git repo. And if these applications will be found there, they will be deployed, converged automatically to your Kubernetes cluster. Yeah, and we see here app for apps dev application, and also important thing that we have a repo URL and some path. Yeah, this is Git repo URL, and we can use any target revision. We can use any branch or something like this from the Git. Yeah. And also we have app for apps for prod, yeah, some bootstrap in some different paths of this repo. and some bootstrap for our projects. Yeah. So we have everything to install Argo CD. Basically, we can just install it. Yeah. To do this, we need to do the standard stuff for Kubernetes. Yeah, we need to add Helm repository. We need to update local cache of these Helm charts. We need to override something if we need it, and just install this Helm chart with override. The next step that we need to do, we need to get some local administrator secret just to get access to the web interface. There's lots of different options that you can use to provide access to your Argo CD instance, but we are using some standard, some basic local user. And also you will need to make port forward to your local port just to have an access to the web interface. And that's it. This is applications that we have. After applying this Helm file, you see that we have 3 bootstrap applications. These applications will wait for the manifests in some Git repo, in some subpaths, and when this manifest will be there, applications will be deployed. Yeah? Just to summarize a bit, yeah. Again, we have OTC software repository with our Docker images. We have infrastructure repository. We have Argo CD inside our Kubernetes cluster right now, and this Argo CD just checks our Git repo and some subdirectories for our application manifest. So we have everything from CI part, we have everything from infrastructure part, and we need somehow to add our applications to all this process, yeah? And actually, that's it. Let's add our applications here. You can see this YAML file, this is applications. This is how you can describe your application. This is custom resource from Argo project, from Argo CD. And yeah, the important thing here that you need to not forget to use kind application. You need to specify some name for your application. And image updater, this is optional annotations. I will come back to them a bit later. Just let's keep it for now. And you need to describe your destination. Basically, in terms of Argo CD, you may have one instance of Argo CD and a lot of Kubernetes clusters that will be managed by this only one instance of Argo CD. And so here in destination, you can specify Kubernetes clusters, and also you can specify some namespaces. And since we don't want to have lots of Kubernetes clusters for this presentation purposes, we have only one Kubernetes cluster and 2 different namespaces like dev namespace and prod namespace, which mean that we have some separate environments for our presentation purposes. Yeah. And also we need to describe source. The source here is, as I said before, some Git repo with some path where our application, where our installation files for this application exist. So in our case, since we are using Helm chart, as I showed you on the directory tree, yeah, there was chart on the top of it. We are using Helm chart, and we can override some variables inside this Helm chart. And as you can see, we are overriding here some image name, image tag, or also we have different Redis URL in different environments in different prod. Yeah. And the same for our production environment. We have some kind application. We have some different name with prod in a suffix. We have image updater that actually we will skip for now. Some destination, again, some source with different subpaths for our production environment, and some different overrides. We say that, hey, this is production. We don't want to use some versions that started from 0. We said that versions started from 1. This is real, true production ready versions. And here we go. We described it like that here. And we don't need to make any installs. We don't need to apply it somehow. We just need to put these 2 files to some specific directories that I showed you before, like stages/production and stages/development, and that's it. As a result of it, after 7 seconds, because this is a sync period that I configured in Argo CD, we will see a new line. Actually, the first line that we saw before, this is our Bootstrap applications, and our applications themselves at the bottom line, yeah. And as you see, synced mark there, a green mark there, which means that application is synced, which basically means that their real Kubernetes state for now and their Git description are equal. This is pretty cool because you can, I don't know, manually accidentally remove some resource from your Kubernetes cluster, and you will lose. You will not lose your resource because Argo CD will check. Hey, I know that I should have, I don't know, 4 replicas, yeah, but I have only 3. I will revert it back or something like this. I should have this config map here with this name, with these values, but I don't have it. Okay, it will be created back again. This is pretty cool GitOps basically stuff, not only Argo CD stuff. And this is how our application details are looking in the Argo CD. Pretty cool web interface. All the resources that we have around our application inside Kubernetes, they are here with the versions. If you will have some different version of the deployment, you will have you can be able to see all replica sets here, you know, everything. You also see here git commit references. You can just check which exact git commit ID or git commit hash sum was used. Yeah, you can have you can use rollback options, and also the top of the screen in the left side you can see application details, and let's check them. As you can see, we have here override that we made in our application.yaml file. For our dev environment, we are using versions like 0.2. And the same for the production. We're also overriding this. We have version 1.7. And let's go back to our application files just to remember this. This is a point where we described, where we hard-coded our versions, our concrete versions of applications. And this is how it looks like in Argo CD web interface. And let's actually check what we have done. And we have application as a code. Do we have it? Yeah, we described our application. We didn't do anything manually. All this stuff was done by GitOps. We have it inside Kubernetes class, inside Git repo, and that's it for us. Yeah, that's cool. Do we have versioning and history? Yes, because we are using Git. We have all these nice features, all this nice stuff that Git have, and this is really cool. Do we have a rollback? I'm just trying to compare this this model with standard CI/CD stuff, you know, where you have some Jenkins and deploy something. In compared to this, do we have a rollback? Yes, we have, and this is I think the most interesting part, because if you are using some old CD process, you cannot just easy rollback your application, you know. And here you can just revert your commit. You can just press some button on Argo CD, and you can easily revert the changes. Yeah, this is great. And reproducible, this is also cool because you can just get our repos that I mentioned before, fork them, make your own Kubernetes cluster, and just apply this, just a few comments, and you will have the same as we have in our presentation. And automated deployment, basically, I would say it's semi-automated, because if you imagine how development process can look like in this case, it would be a bit painful, because you will need to, each time you will need to change the version in your development environment to have the latest version. You know, I want to push commit to some Git repo, and I don't want to make any changes in infrastructure repository to have these changes in the development environment. So I would say for now, no. We don't have fully automated deployment as it could be. And here we are completely come to the Argo CD image updater. Yeah. So what Argo CD image updater actually do? You can specify some additional annotations that I skipped before in some annotations in our application.yaml file. And Argo CD image updater will just, by some politic, by some rules, will just go to your Docker registry, to any Docker registry, and try to get, by this rule that you describe, some concrete Docker image. And this image will be applied to your application. Yeah? Pretty cool stuff. And actually, just to have it, you need to install it. You need to configure it as usual. It's really pretty simple, nothing special there. And you need to add some annotations to your application file because you need to explain to the Argo CD, to the image updater, you need to explain that for this application, you want to have some different versions of your application. You don't want to use only hard code inside of it. Yeah? And you need to choose some strategy. Yeah, strategy means that you need to explain to image updater how he should make a decision which version should be applied. Yeah, to automate this process completely. And you need to choose write back method. Basically, image updater have by default write back method like Argo CD, which means that if it will get some new Docker images, it will change your annotation for your application locally and update your application. Everything will be automated and it's great, but you will not be able to see which concrete version of your application deployed right now on Kubernetes cluster. This is not really cool. This is not really GitOps way, yeah, because in that case, you cannot say that Git repo is one point of truth. For some of your environments, let's say for development, if you will use write back method Argo CD, you will not be able to say this. And this is why Argo CD image updater have also Git write back method, which means that your changes will be committed and pushed back to the Git. This is cool. So how to install Argo CD image updater? You need to just apply some manifest from Argo CD website. You need to generate token for your newly created user, like image updated user. And basically the setup itself, it's pretty much easy. If you need some kind of different options, if you need something like this, please check their documentation. They described everything completely, and I'm sure that you will not have some pain with this. Yeah, and this is our application manifest, and this is our annotations that I actually need to help Argo CD image updater update your images. And we see here the write back method that I mentioned before. So we can use Argo CD, this is default value, and we can use Git, which means that Argo CD image updater will update, will get some Docker images from your repo, from your registry, will update manifest by itself and push these changes back to the Git if you will have write back method Git. You can specify here some images, and at the line 8, you can see the update strategy. In our case, it's firmware 0.x. Yeah. Basically, there are 4 strategies that are available in Argo CD. One of them is firmware range, where you can just specify standard firmware range. I'm sure you're familiar with them. You can use latest strategy, which just always will get the latest image by a regular expression. You can have digest if you are using only one tag, and from time to time you rebuild this tag. I know that this is a bad practice, but unfortunately some companies are using this, so they are rebuilding some latest, I would say, or some test images. And you can also use name strategy that is actually using alphabetical sort. So whatever you need, it can be configured pretty easy. Yeah. So yeah, we have an Argo CD. We have our applications. Let's check what we actually did. Yeah, we installed Argo CD, configured it as we need. Yeah, we used app for apps pattern, app for apps bootstrap scheme to avoid any manual install or applying files or something like this. Yeah. We configured 2 different environments. Yeah, it's namespaces, but we can say that this is actually different environments because we have 2 direct directories. Yeah, and we can put any applications inside of it directories, and which will mean that we have 2 different sandboxes and 2 different environments. Yeah, and we have automated deployment process with image updater. And its strategy, yeah, that I described before. Actually, that's it from Argo CD part. I've finished. I wish it was interesting for you guys, and I would like to ask Alex to continue with Flux CD. Alex?
Yes, thank you, Dennis. I will take over from here and continue. Yeah, Flux. Flux is basically another tool which is doing GitOps. Short overview, it was created by the company VWorks, the same as invented the term GitOps itself. Right now, it's an incubating project in the CNCF. Technically, it runs in the Kubernetes cluster, either in the same cluster with the infrastructure, with the applications, or it can also be in the separated cluster. Under the hood, it uses a set of custom resource definitions that one needs to know in order to describe their workloads. And it has a CLI tool that we can use to install it, to manage it time after time, or to see what's going on. All right. Since it's a GitOps tool, one needs to somehow give it access to the Git repository. In our example, we will be using GitHub. So to start using Flux, one needs to have a GitHub token. And then we pass this GitHub token to Flux by means of its CLI command. So here, when we create a new Flux installation, we need to give it an owner, so basically a token. We need to point it to our repository URL. We need to say which branch will contain the source of truth, and yeah, some other parameters. This is the default settings. In our setup, we will go a little bit wider. We will add another parameter, which is called watch all namespaces. Why? Because we want to have both production and staging environments running in the same cluster, but in the different namespaces. And by default, Flux will manage only a namespace in which it's running by itself. And in our case, we want Flux to manage more than one namespace. And another part that, another extra flag that we want to use, we want to a little bit extend our Flux. I will show you later, it will be automatically writing back to the Git repository. That's why we need to tell it explicitly that it needs to have write access and to have extra components installed. After you execute this command, there is a command flux check, which can basically go to the cluster and take a look what's running inside. And as soon as there is a message, all checks passed at the end, you are good. We can take a look at the cluster, and as you can see, by default, Flux creates a namespace, which is called Flux System, and installs itself to this namespace. We can go there and take a look what is running there. And as you can see, under the hood, Flux is a set of so-called controllers, which are which provide the main functionality of Flux. So here you can see that we have a Helm controller, we have image automation, we have customized notifications, and basically their names explain for themselves. Okay, let's take a look about the structure of the files on the disk. So in the infrastructure repository, there is a folder called Flux, and this folder contains everything you need to set up your Flux in your cluster. So the first application folder will contain YAML objects related to our own application, that one which is written in Go language. The next folder clusters will contain workloads for different Kubernetes clusters. So here, basically, we will have different files for production and different files for staging. Image update is a folder which will contain information how Flux should automatically update versions of the images that it uses. Infrastructure folder will contain third-party applications. In our case, this is Redis. In general case, it can be a bunch of other third-party applications that one use. And an install folder, it has just a dump of Flux installation files. So it means that if you decide for some reason to switch the whole infrastructure from one cluster to another cluster, then you can skip running a Flux CLI tool again, but instead you can just do kubectl apply of all files in this folder, and you will get the same Flux as you had before. Okay, let's consider a little bit our application. Usually, when you ship an application, you need to ship the application itself, and usually it comes with a bunch of dependencies. So in our case, we have application which we write ourselves, so it's in Git and it's written in Go. In terms of infrastructure, our application is described by Kubernetes objects. We have very simple application which is pretty much simple, and so it can be described using basically 3 files. With third-party dependencies, the situation is a little bit different. Here we don't need to have a source code of third-party dependencies. Instead, here we want to say that we want, for example, Redis of version 11.3.4, MySQL of some version, and so on and so forth. So here we don't need the latest version in the general case. Instead, we want some version that is believed to be the production ready or some other specific version. And here, this is the difference because when you work with your own application, most of the time, the only version that you care about is the latest. It's like the most recent commit from your main branch. Meanwhile, when you need to install some third-party dependencies here, usually you go for strict versioning, and you say that I need exactly this version because other version may not work with my application. There are 2 ways how to compose applications in Kubernetes. One of them is customize, and another is Helm. In this presentation, I will use Helm for installing third-party dependencies because Helm is something that takes versions seriously. So you cannot install Helm chart without specifying the desired version. And for our own application, we will not use Helm because we don't want to go wild with different versions. Instead, we will use Customize. Customize is a tool that basically doesn't have versions. Instead, it's like what you see is what you get at the end of the day. And this is a very great tool when you need to deploy your in-house application, the latest version somewhere. Both of these things we will manage with Flux. Let's start with the third-party dependencies, how we install third-party dependencies with Flux by means of Helm. If there were no Flux, you would need to add a repository of one of the Helm repository, and then you need to Helm install a specific version of it. In the Flux world, it's pretty much the same. You need to create 2 Kubernetes objects. One will represent the Helm repository, and another one will represent the Helm release, where you define the exact version that you need. And then you put these 2 files in your Git repository. And after this, somehow magically Flux will take care. We will take a look at this later. Our application. As I said before, our application sits in the folder called app, and there it has a folder called base. This is basically this is where all our Kubernetes YAML files are. And we use Customize, as I said before. And here we can use Customize for different environments. So as you can see here, we have a base version of application, which is just like some kind of like abstract version, and we have some specific adjustments for production, and we have specific adjustments for staging. As a typical example, for production, like what customization can do for you, it can, for example, adjust the version of the Docker image that you use in your deployment. So in this case, for example, on production, we want to run version 1.42.0, which is supposed to be stable according to the semantic versioning. Meanwhile, on staging, we would like to use dev version. And if we put these changes to the corresponding customization files, we can overwrite the base values which are in the base folder. And this means that for production, we will have one version, and for the staging, we have another version without doing any changes in the base versions. This is very useful for having different environments in different clusters, or just having different environments in one cluster. And after this, you need to tell Flux, please take care. And basically, how does it look like? You just need to specify interval, how often Flux should check for new changes in the given folder. And then, the path, basically, it's a path to the folder with either customization files or Helm files. That's it. After this, Flux will take care. So what we saw is that Flux can install packages from both Helm, as well as it can combine packages using customize and install them to the cluster. What is common in this scenario is that always Flux takes files from Git and then somehow installs them to the cluster, which means that Git becomes a crucial part of your whole infrastructure. Let's elaborate a little bit further on Git. Nowadays, most of the people, they use some continuous integration tool, let it be, for example, GitHub Actions in our case, which means that upon each push to the specific branch, there is some workflow which is running in the GitHub Actions, which can do some magic. Let's say that this workflow is responsible for baking new Docker images. So what we have, that upon each request, upon each new push to the specific branch, GitHub Actions will create a new Docker image and push it to the registry. This is exactly the CI part of the CD pipeline. What we have seen before is that Flux can also take the latest state from the Git and apply it to the Kubernetes cluster. But right now, the pipeline is not fully automated. So GitHub Actions will bake new images and put them to the registry. But somebody needs to persist these new versions of the Docker images in the Git repository. And Flux can do it for you as well. It has a component which is called image update automation, which is essentially every X minutes just looking in the Docker images. And as soon as there are new Docker images which match regex according to the semantic versioning, it commits these new versions back to the Git. And then Flux will take care about applying this new state of the infrastructure in the cluster. So as you can see, this covers the CD part of the CI/CD pipeline. So this is how Flux can be used for the fully automated CD part. Let's take a look a little bit deeper in this image update automation guy. To start using it, you need to add the image repository. So you basically need to tell it where are your Docker images, and give it some access there. Then here you can specify a rule, basically which versions of images should be taken into account. This can be different rules for production and test environment or pre-production environment. So in this case, we see that basically all the images which versions start with 0 will be taken into account. And then there is a glue in between. We go back to our customization file for staging in this case, and customization can do overrides. And in this case, we say that please overwrite the new tag of our Docker image that we use. And then the crucial part here is that commented string, which is some kind of magic that you tell Flux, please replace this new tag every time when there is a new image in the Docker registry. And Flux will do it for you. So effectively, it will commit and push an updated value for the new tag. This is how it looks on the GitHub. So you had a 0.27.0, and then there was a new image 0.28.0, and Flux discovered this new version automatically and pushed this commit back to the Git repository also automatically. So this is what we had before. This is the fully automated pipeline. Full optimization is great most of the time. However, sometimes there are situations that you would like to keep an eye on what's going on, especially I'm talking about more production environments. In this case, Flux image update automation can skip the part with pushing to the Git repository right away. And instead, it can open a new pull request in this Git repository, and then a corresponding responsible person, let it be some operator or administrator or DevOps guy or team lead or whoever, depending on the company, then a human in the middle can make a final decision whether we commit this change, or we merge this change, or we don't merge this change to the main branch. Because as soon as this is merged, a Flux will take care to apply it in the cluster. How to set it up? As we saw before, there is image update automation tool, and it has two parameters. It has a branch from which it has a push branch. This is basically the name of the branch where it will push a new version of the Docker image. And if you change this to some specific value, so in our case, this is the last line, this is the production update branch instead of main branch, then you can, if you are sitting on GitHub, you can set up a corresponding GitHub workflow, which will create a new pull request for each new commit to this production update branch. And then it can assign automatically a responsible person to this pull request. And that's it. And so basically, Flux image updater will never commit back to the main branch. It will only commit to this production update branch. And every time this will be a pull request to the main branch. All right, that were the main features of Flux. What are basically main takeaways? First, it comes with a CLI tool that is great. You can use it for Bootstrap. You can use it for getting some logs. You can use it for debugging on what is going on. Flux supports customize out of the box. This is very useful for your in-house application. Besides that, Flux supports Helm out of the box. This is useful for your third parties and something that you want to install from the internet. Flux can automatically update Docker images, versions of the Docker images that it uses, and it can persist it in the Git repository or even create a pull request so that some operator in the middle can make a final decision whether we want to deploy this or not. Okay, let's go to the final slide. Basically, today we have compared two tools which are doing pretty much the same job. And we want to know who is the winner. In our case, what we think that both Flux and Argo CD are excellent production-ready tools that can implement GitOps. They automate a significant part of the software delivery pipeline. They increase the frequency of deployments. They enable all who can use Git to manage Kubernetes-based infrastructures. Our company has experience with both Flux and Argo CD. And usually we decide what to use in the specific project with the client after reviewing their requirements and considering their individual needs. Both tools, they have slightly small advantages and disadvantages. However, the main point is the winner is everybody, because we can clearly see that more and more technology companies adopt GitOps to do continuous delivery and operate Kubernetes clusters nowadays. And we strictly believe that this is one of the new significant changes in the industry. And after all, the more awesome GitOps tools we have, the better for the industry. Thanks a lot for your attention.
And with this, thank you, Alex, and thank you, Dennis, for this great webinar here we had together with you. Thank you all for participating, and see you in the next webinar. See you. Bye.